All right. George or Jose, or not Jose, Jorge is factoring a quadratic expression. First, he factors out the greatest common factor, and then he uses grouping. Which expression could be George's expression? So they say that the first thing he does is he factors out a greatest common factor. So we got to look at these and see which ones can have a greatest common factor. But the key is factor by grouping. So this one, because there's only two terms, I can pull out a common factor, but I can't factor by grouping, okay? So that one won't work. You might think, well, this kind of looks like a difference of squares, except there is no square root for 7. So it's not that. So it's either A or C. I think that it is A because the greatest common factor is 3. So I could pull out a 3, and that would give me 2x squared minus 3x minus 20, not 27, minus 9, right? Because I got to remember I'm pulling out the 3. So then so basically I have to factor this to see if I can factor it by grouping. So I've got my greatest common factor here, and then I'm going to pull out another greatest common factor here. So remember, to use the AC method, I have to find two terms that when I add them up, they equal B. But remember, B is -3. And when I multiply those two terms, they equal A times C, which is, in this case, 2 times 9, which equals 18. So, it's 2 times -9, so it'd be -18. 2 times -9, because C is negative. So I think that -6 times a +3 gives me a -18, and then -6 plus 3 gives me -3. So then this middle term here becomes -6 plus 3x, right? These are -6x and plus 3x, and everything else is here. So in the next step, then, I'm going to factor out 2x here, and that gives me x minus 3. I'm going to factor out a +3 here, and that gives me x minus 3. I can factor out the x minus 3, and I get 3 times x minus 3. And then what goes in here is this 2x plus 3. So A would work. Now, I could go through that same process with C, but I found one that works, so I'm not going to go any further. So A is the correct answer.